Today, as you see, we have so many lenses in front of us. Lens is a very crucial part of a camera, though technically a lens is separate from a camera body. The purpose of a lens is to make a sharp image onto the image plane. Therefore, it focuses light or it collects light, and because of the property of the lens, of the property of the glass, it enables to collect light from a wide angle area and focus it or make a sharp image on the image plane. In most of the cameras, as you would have seen, there is a lens and there is a camera. The lens gets light rays and the film which is stretched across the back of the camera, it is there that the image is formed. Have you ever thought that can an image be formed without a lens? Yes, as we had talked earlier, the pinhole camera used to do that. We know that even if there is a small hole, a fine hole in front instead of the lens, the light rays will form and form sharp, but a very weak image. The camera lens replaced this. The property of the lens enabled to make a sharp image which was very bright compared to a pinhole image. This is because by nature a camera lens is like a convex lens. It is round on both the sides. When light strikes the lens, it bends. It bends or it converges. You may have seen this experiment or have done this experiment in as a childhood exercise, where you use a magnifying glass, which is also a convex lens, to burn a sheet of paper. Why does the sheet of paper burn? Because light rays from the sun which are travelling parallel to each other, when they hit the convex lens of a magnifying glass, they bend or they converge. They converge on what is called the image plane or on a certain point, which will be a little distance, maybe half a feet away or 6 inches away from the lens. When the light rays converge there, naturally it generates heat and the paper burns. Similarly, the light rays, when they hit the lens, they converge and form an image on the what we call as the image plane. On the image plane is stretched the sensor or the film. Now, a lens is crucial to a camera, not just because it forms an image, but because of the properties of the lens, we can create different kinds of images. The same face, the same scenery can have varying characteristics because of the properties of the lens. That is why you may have heard in normal language about the telephoto lens or a normal lens or a wide angle lens. Most of us who watch television, who watch sports on television, see that while watching a cricket match, you can get an image from a great distance of the person far away, or even wildlife photography, we can see a close up of a tiger from far away. That is a telephoto lens, because it has brought the subject which is far away very close to us. This kind of property of a lens is dependent on one very fundamental property, which is called the focal length. Every lens has a focal length. Focal length technically is the distance between the rear nodal point of a lens and the surface or the plane on which the image is being formed when the light rays are travelling from infinity. Let me explain this further. When light rays are travelling parallel to, when I say infinity, it means from great distance, which means when the light rays are travelling parallel to each other from great distance, when they hit the lens, when they converge on a certain surface, the distance between the lens and the surface here, which is called the image surface, is the focal length of that lens. You may see here right now on the camera there is a 50 mm lens. Now, this is a 50 mm lens. A 50 mm lens in photography terms is called a normal lens. The characteristic, the kind of image a 50 mm lens produces is something like what normally our eye sees. There are two factors. One is magnification of an image, the other is angle of view. How big an image you see and what amount of angle of view you are seeing. When the angle of view is really narrow on the entire surface of the film plane, just my face or my eyes are formed, then the image is brought closer, the image is also magnified. Such an effect we get with a telephoto lens. A telephoto lens technically has a focal length of more than 50 mm in this kind of camera. A 100 mm lens will create an image which will be bigger, or which will bring the subject closer, but by bringing the subject closer it will also lose the angle of view, the angle of view will contract. Now, I need to explain this much better to you, because it should not be understood that a wide angle lens or a telephoto lens or a standard lens or a normal lens are governed by more than 50 mm and less than 50 mm. Any angle, any lens which is less than 50 mm in the kind of photography that we do is defined as a wide angle lens, because it makes the size of the subject smaller, but it includes a wider area. When you use a 50 mm lens, a normal lens, it contracts and makes us show the image as a normal eye would see. And further, if we add telephoto or we add a lens of more than 50 mm lens, say 100 mm or maybe 200 mm or maybe 400 mm, then the image gets magnified closer, but in that pursuit it also gets, the angle of view gets narrower and narrower. This relationship or this quality of the focal length and the characteristic that it shows is governed by the size of the frame of the film. A film size or the frame size, the diagonal of the frame size is usually the same, or the diagonal of frame size in this kind of a film camera that we have been using is something like close to 50 mm. That if the diagonal of the film frame will create an image which will be a normal image. So, the diagonal should be the size focal length of the lens. In this case, the diagonal is about 50 mm. Therefore, we use a 50 mm lens to create a normal image. Anything which is more than 50 mm creates an image which grows in size with a narrower angle of view. Any focal length that camera that we take which is less than 50 mm captures more on the frame area. Therefore, it creates a wide angle appeal. Basically, lenses are classified in three kinds: the wide angle, the normal and the telephoto. But now lens technology has improved so much that in one lens like you see here, we can have variable focal lengths. By moving the barrel up and down, I can have a wide angle lens, a normal lens and a telephoto lens in the same lens. This kind of lens is called a zoom lens. A zoom lens is a lens with variable focal length. People generally confuse a telephoto lens for a zoom lens. They feel that any lens which brings the distant thing closer is called a zoom lens. No, that is a telephoto lens, because it has a telescopic effect. Its focal length is more than normal, therefore, the distant object has come closer. But a zoom lens is a lens which zooms in and zooms out. It is easy to understand that effect, because we see that effect a lot in television, etc. When we change the focal length of the lens on shot in a movie or in a video, then we can see the image, the angle of view being reduced and simultaneously the size of the image growing. That is a zoom effect, or the camera is changing its focal length. So, variable focal length lenses are called zoom lenses. Since we are on the topic of the types of lenses, there are other lenses for specialized jobs. A micro lens is really like a microscope. It enlarges very small objects many more times. So, a micro is used to shoot very fine objects and to make them look bigger. But another a much more common thing, a lens which is confused as a micro lens, is called a macro lens. A macro lens allows us to focus very close. So, small objects, one can take the camera very close to them. So, a grain of rice, I can go very close to it and focus and create a relatively larger image. You focus on a certain image, you look through and you, by moving the lens elements inside, you sharpen a certain object that you are wanting to photograph, whereas focal length is a fixed characteristic of the lens. This is a 50 mm lens, but I will have to focus it either here or there or here. So, focus and focusing means sharpening the image on the image plane. The issue of focus and focal length should not be confused. As I have been mentioning, there is a strong relationship between the focal length and the look of the image. It is not just the focal length of a lens which governs the look, but it is also the aperture that we set the camera on. The aperture or the iris is embedded inside the lens, therefore, it is crucial to the look of the image. Aperture first of all controls depth of field. Depth of field is the area of apparent focus before and after the actual point of focus. To explain this better, you must have seen images where at a certain line or at a certain object is very sharply visible in focus, but areas behind and in front of it look blurred. On the contrary, you may have come across images where everything, the first person, the person behind and the person even behind, everything looks very sharp. This is what is depth of field. Depth of field is good or high when everything is in focus beyond and in front of the actual point of focus, then it is deep or great depth of field, whereas the depth of field is really shallow when objects in front of the actual point of focus or behind the actual point of focus are seemingly blurring. Now, there is an interesting relationship between the focal length of the lens and the size of the aperture, which determine this. For any basic photographer, it is very important to know this. Lenses with focal length on the higher side, on the tele side, have shallow depth of field. Lenses which are wide angle or less than 50 mm create good depth of field. So, for any photographer who wants good depth of field, one should use a wide angle lens or a normal lens rather than a telephoto lens. On a telephoto lens, you have to be very critical about getting sharp depth of field. Why is this so? Again, I will take you back to the aperture. The size of the aperture here is important. Any image formed through a lens, when the light rays pass through a lens, they also pass through the iris or the aperture opening. The image that is being formed on the image plane is receiving light either from a wide aperture or from a very small aperture. When light rays go through a very small aperture, the image is very sharp. Try to understand like this: an image is formed of circles. If the aperture size is big, the image will be formed of bigger circles. When the image will be formed of bigger circles, then the overlapping of the circles will be visible, and when the overlapping of the circles will be visible, the image will not be so sharp. It will only be sharp on the sharply focused plane. Objects behind and in front of it will look blurred. The term to explain this is also called circles of confusion. That is why we say when the aperture is big, the circle of confusions are big. Since the circle of confusions are big, image looks blurred behind and ahead of the actual point of focus. Whereas, when the image is formed through very small aperture, the circles are small which are forming the image, and their overlapping is also not visible, because there are small circles which are overlapping. Therefore, there is greater depth of field. Therefore, there is a greater area of apparently good focus. So, this is governed by the size of the aperture. Now, it is interesting to know that aperture size is not the same for all focal lengths. Here there is a 50 mm lens, there are other lenses also. Here there is a 135 mm lens, here there is a 28 mm lens. Now, as I had told you earlier, say if it is f4, f4 here, f4 here, f4 here for a telephoto, for a normal and a wide angle, the actual diameter will be different. Where for a telephoto lens, an f4 size will be much bigger, the real diameter opening, than compared to a normal lens where it will be smaller, and for a wide angle lens where it will be much smaller. There is a formula to this. The actual diameter opening is equal to the focal length of the lens divided by the f stop. So, if the focal length is 100 and the f stop is 2, then the actual opening is 50 in millimeters. The 100 mm lens will have an actual opening of 50 millimeters, but just change that 100 millimeter lens to a 50 millimeter lens, the actual opening for the same f stop for 2 becomes 25. So, you can see that the aperture, the actual relative opening is changing. When the relative opening is changing and opening up or becoming smaller, it is affecting the depth of field. By affecting the depth of field, it is affecting the look of the picture. So, in all practical terms, to have a shallow depth of field, one uses a telephoto lens. To have a greater depth of field, one uses a wide angle lens. So, this is a very important crucial point. The actual aperture size affects the depth of field. This is the point that I wanted to emphasize more and more. As I had told you earlier in the earlier episode also, that the iris is embedded, the aperture is inside the lens, light rays pass through them. A wider aperture, where as you can see on the aperture ring, I can change it from 16 is the smallest aperture, then there is 11, then there is 8, then there is 5.6, 4, 2.8, 2 and 1.4. 1.4 is the widest aperture, whereas 16 is the smallest aperture for this particular 50 mm lens. On any lens, there is a zone which shows us the depth of field. It is important to know, as you can see here, all aperture readings are marked in different colors. 16 is marked in orange, 11 is marked in blue, 8 is marked in white, 5.6, 4, 2.8, 2 and 1.4 are all marked in white. Corresponding to 16, if I put the aperture at 16, there are 2 markers which say 16, and ahead of that is the focusing ring. Now, when I am shooting at 16 and if I am focused at 2 meters, by corresponding the orange marks, I can make out that anything, though my sharpest focus is at 2 meters, anything which falls between the orange zone, which is 3 meters and 1.5 meter, will be all be in focus. So, the lens is telling me the zone of focus, whereas the blue line which is inside the orange line contracts the zone of focus. Now, if I was shooting at 11, I can easily find out that now the zone of focus is not between 3 and 1.5 as it was in 16, but now it is inside 3 and inside 1.5, which means something like 2.5 and 1, which is showing me the zone of focus. So, on all lenses there is a chart, there is a zone of focus display which shows the depth of field. The depth of field can also be gauged by what is called the depth of field preview button. By pressing it, the iris locks. The only thing that happens disturbing is the image also becomes faded, because the light is now much less light is coming, but by training one's eye, one can see when the image is locked, then you can see the actual zone of focus, which you can't see when you normally view through viewfinder, because in a normal viewing mode the entire iris is open. So, depth of field is very closely related to the lens quality and the lens. So is the focusing zone. Now, the third thing which is important, which is dependent not so much on the lens, but the distance from the lens is what is called perspective. Perspective is our ability, how our mind sees a 3-dimensional image on a 2-dimensional plane. Perspective is controlled by the subject or the camera to subject distance. Subject 1 is 1 feet away from me and subject 2 is 2 feet away from me, the subject 2 will be half the size of subject 1. This is important because it matters when we change focal lengths. Because of the characteristics of the change in focal length, we have to move forward and backward, keeping a certain object in place. When we look at a certain object, say if we are doing wildlife photography and there is an animal, a tiger far away, and I use a very telephoto lens to photograph it, the object is coming close to me, but it is also looking a bit flattened. This is because of the perspective has been flattened, because of the relative distance. The subject itself, the tiger itself was 100 feet away from the camera of the telephoto lens. There was maybe a wall or a tree 10 feet behind it. So, the tiger which is 100 feet away and the tree which is 110 feet away from the camera both look compressed because of the distance from the camera. But in another situation, imagine if there was a wide angle lens and the subject, a close up subject was 1 feet away from the camera and another subject was 10 feet away from the camera, the relative size of the two objects would be such that the 10 feet away object from the camera would look really small compared to the subject which was 1 feet away, creating an exaggerated perspective. Therefore, it is said that one should not use wide angle lenses to photograph portraits or close ups of people, because the area of the face, say the nose which is closer to the camera, looks a bit enhanced compared to the ear which is farther, which may look small. Perspective is not dependent on the lens, but it is dependent on the distance from the lens of the subject, but the quality of the lenses is such that it affects the look. So, therefore, it is said in common knowledge, or it is said in common language, that perspective is really enhanced or exaggerated by wide angle lenses, whereas it is kind of compressed or flattened by telephoto lenses. So, as we have seen, it is very important to recognize lenses. Every lens has certain very important details imprinted on it. Either it is inside a lens on the rim, as you can see here. This is a Nikkor lens 50 mm. 50 mm means its focal length is 50 mm. It also says 1:1.4. There is another lens I will show you. Here it is on the lens hood, its quality is mentioned. It is a Nikkor lens 135 mm. It says 1:2.8. These details, properties are very important. The make is there, the focal length is there, and 1:2, 1:2.8, 1:1.4. That means this lens opens to 2.8, this lens opens to 1.4. A quality lens is a one, how much light does it allow, how maximum does it open. A 1.4 lens is a very good lens, which means it is a fast lens, which means it can operate well with a fast shutter speed in low light conditions, because you can allow 1.4 aperture setting will allow maximum much more light than the 2.8. It does not. Here you as you can see, there is a setting 1.4 to 2.8. So, it actually opens 2 stops more than 2.8. So, it allows much more light than a 2.8 lens. As the lens gets longer or becomes more and more telephoto, since it has to travel through a longer barrel, as you can see here, light gets absorbed. Therefore, it is very difficult to have a good opening, a good maximum aperture opening in a telephoto lens. a very good telephoto lens will open to 2.8, or if it is a super telephoto lens, it may open just till 4 or 5.6, which means it does not allow more light than 5.6 to come into. So, it is important to see the quality of the lens by judging how much does it open. A maximum opening, the better, the more the maximum opening, the better quality lens it is called, or a lens which is. Similarly, if you are not using if these are all fixed focal length lenses, this is a 50 mm lens, this is a 135 mm lens, but if you were using something like a zoom lens, then you can see here it says 17 to 35. This lens zooms from 17 mm to 35 mm, and there is a zoom lens ring, as you can see below that. Here the lens zooms from 17 to 35. So, the focal length, this is a wide angle zoom, it zooms from 17 mm to 35 mm. This is another very interesting lens that we have here. It is called a fish eye lens. As you can see, it has a dome kind of an effect. It is called a fish eye lens. Why? Because it is an extreme wide angle lens, meaning its focal length is just 16 mm. A 16 mm lens has a fish eye view, like a fish which does not have a neck and cannot see in all direction. It has a wide angle area of view. A 16 mm lens enables us to see or accommodate a very wide angle area. It is important to say though that lenses, because of their changing in focal length, extreme wide angle lenses, because they are seeing a wide area, covering a wide angle area, certain aberrations or defects start creeping in. You may have noticed through images in press and in television, images on the periphery start getting bending down. This is called curvilinear distortion. Things become curved in a wide angle lens. There is also a perspective distortion. Again, things closer to the lens look very big, and things far away look much smaller. So, distortions are also inherent because of the glass, because any lens is a compound lens. A lens is not one single concave lens, because by putting a number of lenses and combining them into one is trying to remove certain aberrations which come with the quality of glass. So, making a quality lens is not a very easy thing. A general recommendation finally, anybody using a lens, a camera, should be very careful about the lens being well protected. No scratches should come on a lens. Therefore, one generally as a protection puts a UV filter, because it protects the actual lens from scratches, from touching, etc. One should always, after or before a shoot, clean one's lenses with a very soft chamois leather or a cotton cloth, which does not, and we should be, or use an airbrush to remove all the dust. In today's episode, we saw how the lens affects the image in a camera and the importance of a lens in making an image. Hopefully, we will look into more issues of photography in the coming episodes. Thank you very much.